So many ask, how do I solve for x when it's an exponent? In this video, we're going to look at how we'll solve questions that are similar to these exponential equations. Now, when a question becomes an exponent, many wonders how they can go about solving such question. Now, imagine when you are given a question like 3 raised to power x equal to 5. Now, this question is very different compared to when you are asked to solve for x and you are given 4 plus x equal to 6. All you do is what? Over here, you take 6 over to this point, 4 over to that point, which will be equal to 6, and it becomes negative 4. And then your x is equal to what? 6 minus 4, that will be equal to 2. But that's a different case when it comes to exponential equations or finding x in this regard, because x is an exponential value. What if we can solve this using the value log raised to power log 5 over log 3? Now, if you simplify log 5 raised to power log 3, what are we going to get? Now, let's use a calculator. If you don't have a calculator, you can Google your calculator on Google, and then you use the calculator on Google. Now, let's find log of 5. Find log of 5 is going to give you 0.6989. And then when we write that down, we are going to also go ahead to look for log of 3. Now find log of 3, and that will give us 0.4771. Now let's go back to that equation. The log of 5, which is 0.6989, which we have written down, and the log of 3, which is 0.4771. If we go back to that equation, you come to find out that when you divide that, you come to see that your value will be equal to 1.4648. Now let's try that out. If we raise this to a power, and let's look at 3 raised to power 1.4648. If you raise this power, you use your calculator to find the power of 3 raised to power this is going to give you 5.000145. So you see, it's similar to what? 5, which tells you that solving questions like this, converting them to using the logarithm can be a perfect solution. Now let's try using showing you the format in which we solve this question. Now, if you are given that question, you are given 3 raised to power x equal to 5. What you need to do is the first step is to take the logarithm of both sides. So this will give us log of 3 raised to power x equal to log of 5. That will be log of x base 3 equal to log of 5. So this x will move over to this place according to the laws of logarithm. That will give us log x log 3 equal to the log of what? 5. So what we need to do is we'll have to divide both sides by 3, log 3, in order to take away find the value of x. So log 3 divide this other side by log 3. If we do that, we're going to have log 3 clear log 3, and then our x will be equal to log of 5 over log of 3, which is equal to that value 1.4648. That's the value of x. So our x will definitely be equal to 1.4648. Good. Now let's try another simpler question. similar to this, in which we have to use the logarithm format, so long as it's an exponent with different base. This specifically will help you solve exponent with different base. When we have 5 raised to power 2x plus 3 equal to 8. Now, these are exponents with different base. To do this, we have to take, the first thing you need to do is take the log of both sides. So we'll have log of 2x plus 3 to base 5. That will be equal to log of what? Log of 8. So this whole part will move over here according to the laws of logarithm. We'll have 2x plus 3 log of 5, and this will be equal to log of what? 8. Now, in order for we to get the value of 5, we can simply divide through by log of value of x, we'll divide through by log of 5. If we divide here by log of 5, we'll divide this other end by log of 5. So log of 5 will simply clear log of 5, and we're left with what? 2x plus 3 equal to log of 8 over log of 5. Now let's go back to our calculator. Let's go back to our calculator to look at the value of log of 5, log of 8, and log of 5. Now, if we go back to our calculator, we'll have our log of 8 will give us 0.9030. We'll write that out, and then the next thing is we'll look for a log of 5. Log of 5 is going to give us 0.6989, and then we'll write out that out. So if we divide this value, those value we've gotten, we'll get log of 8 over log of 5 to be equal to, we'll have our 2x plus 3 to be equal to 1.2921. So if we simplify, we're going to take 3 crossing over to this point to become negative 3. So we'll have a 2x to be equal to 1.2921 minus 3. So if we simplify, we are going to have 2x to be equal to minus negative 1.7079, and we'll divide both sides by 2 to make a way for the value of x, and then we'll have our x to be equal to a negative value. We'll have our x to be equal to a negative value 1.7079 divided by 2, and that will give us a negative 0.854. Now let's check this out to see if our results can be correct. We are asked to find 5 raised to power 2x plus 3. We want to find out if this actual value can give us 8. So we'll have 5 raised to power 2 into bracket minus 0.854 plus 3. If we simplify that, we are going to have 5 to be raised to power this multiplied by minus 0.854. That will give us negative value of 1.7079 plus 3. So for add that, we'll have 5 to be raised to power 1.2921. Now, if you pick up your calculator and find 5 to the power of this, you're going to find out that it's going to give you 0.00090, which is what? Which is also 8. So that tells us that our solution using the log or finding the log using the log of both sides is absolutely correct. Now let's also try another question. You might also be asked to find a 3 raised to power x plus 2 to be equal to 4 raised to power 2 minus x. Now we'll see that they have different base. So once you notice the base are different, all you need to do is to apply the logarithm format. So we'll take the log of both sides. Log of 3 x plus 2 base 3 equal to log of 2 minus x base 4. Now, if we take log of this log of both sides, you'll come to see that this will come over here, while this will also come over here. So this will give us x plus 2 log of 3 equal to 2 minus x log of 4. So in order to find the value of x, all we need to do is to divide both sides by log 3. So we'll divide both sides by log 3. We'll divide this end by log 3. So if we divide here by log 3, this will clear this, and then we'll be left with x plus 2 equal to 2 minus x multiplied by log of 4 over log of 3. Now let's go back to our calculator. We're going to find the value of our log of 4 and log of 3. If we go back to our calculator, we're going to find the value of log of 4 and log of 3. Log of 4 is going to give us 0.6020, and then we'll have a log of the log of 3 is going to give us, log of 3 is going to give us 0.471771. So we'll divide it. Once we divide it, what are we going to get? If we divide those two parameters, we are going to arrive at a value. If you divide that, you will have your x plus 2 to be equal to 2 minus x, and it will be multiplied by 1.2617. So the division of these two will give us 1.2617. So what do we do? 1.2617 multiply this, and it will also multiply this. So what we'll have a system in which we'll have x plus 2 to be equal to 1.2617 multiplied by 2. If we multiply that by 2, we're going to have 2 points. We'll have 2.52. Pointing my calculator, 5235, and then that will be minus this multiplied by x, and that will give me minus 1.2617x. Fine. So all we need to do is to collect the like terms. If we collect the like terms, we'll have our 2 going over here, and then our x coming over here. First of all, we are going to take 2 back to this side. So we'll have x plus 1.2617x, because this is negative 1.2617 crossing over to become positive, and then we'll have 2.5235 minus what? 2, and then this is going to give us this value here is going to give us this plus this will give us 2.2617x, and this will be equal to this minus this will give us 0.5235. So that's the value we get from our calculator. So we'll expand divide both sides by 2.2617, and then we'll divide here by 2.2617. If we divide that, this will clear this, and then we'll have our x value to be equal to this value divided by this, which will give us 0.2315. And so if you substitute this value into the initial equation, you are going to find out that the real value of x is exactly what it is. So this shows you that we can truly solve exponent exponents when they have different words, different base. So we're going to also look at what if in a situation you are given an exponent where both of them have different base, but we don't need to apply the laws of, logarithm or bringing in logarithm in order to solve them. Now let's analyze two examples. We're going to look at two examples. Now assume we are given a question like this: 27 raised to power x plus 1 equal to 9 raised to power 3 minus x. So if you are given this kind of question, you don't need to raise both sides into a power of you don't need to use the logarithm. All you need to do is just to simply find the powers of 27 and 9. Remember, 27 and 9 can be reduced to a given factor. This will be 3 raised to power 3 because 3 times 3 times 3 will give us 27. So this will give us x plus 1. So as long as we can reduce this value to something like this, we don't need to use the logarithm. So this will give us 3 raised to power 2, and this will give us 3 minus x. Fine. So this value, according to the law of indices, this will multiply everything here. So this will give us 3 into bracket 3x, 3 times x plus 3, and that will be equal to 3 raised to power 3 times 2, that will give us 6 minus 2x. So for have that, we'll simplify to give us, we have one common base. The common base will have to clear the common base, and then the exponent or the powers will equate. And then we'll have our 3x plus 3 equal to 6 minus 2x. So in this point, we need to what? Collect like terms. This will come over here to give us a positive 2x, and this will come over here to give us a negative 3. So this will give us 3x plus 2x equal to 6 minus 3, and this will give us 5x equal to 3. And finally, you come to see that if we divide both sides by 5, divide both sides by 5, we'll have x to be equal to 3 over 5. So this is the solution to that exponential value. So this shows us that some exponential problems you don't need to use logarithm because they can be what? They can be simplified into some various what? Factors. Now let's try another question. We'll be given we are given 4 raised to power x plus 2 equal to 8 raised to power 3x minus 1. Now I want you to pause this video a little and take your time to solve this question. Let's take your time to try this out to see if you can solve it. Now let's solve this. Since 2 can be equal to 2 raised to power 2, and this will be x plus 2, and this will be equal to 8 can be 2 raised to power 3. 8 can be 2 raised to power 3, and this will be equal to 3x minus 1. So this will definitely give us 2x raised to power 2 raised to power 2x plus 4, and this will be equal to 2 raised to power 9x minus 3. So you see that we now have a common base, and in this situation, since we have a common base, the common base will clear the common base, and then we'll have 2x plus 4 to be equal to 9x minus 3. So in these terms, you have to collect like terms. We'll have 2x, positive 9 comes over here, positive 4 goes over there. Positive 9 comes over to give us negative 9, and that will be equal to minus 3 minus 4. So this will give us 2 minus 9 will give us 2 minus 9 will give us a negative 7x, and this will be equal to a negative 7. So the negative will clear the negative, and then what we'll have remaining, we'll have this part divided by 7 and this part divided by 7 to find the value of x. So over here, x will be equal to 1. Now, if we slot this out to check out the value into the equation, we have our 4 raised to power x plus 2 equal to 8 raised to power 3x minus 1. So if we allow our x to be 1, we'll have our 4 raised to power 1 plus 2 equal to 8 raised to power 3 multiplied by 1 minus 1. So this will give us 4 raised to power 3 equal to 8 raised to power 3 minus 1. So that will give us what? This will give us check value 4 raised to power 3 equal to 8 raised to power 2. So we see it's equal. 4 raised to power 3 is 64, and then 8 raised to power 2 is what? 64. So that shows that x is indeed 1. So you see, in many instances, you don't need to apply the logarithm. Now let's look at one final question. If you are given 16 raised to power 5 x minus 2 equal to 32 raised to power 3x minus plus 1. Now if we try this, I want you to pause this video and try this question out. Give this question a shot, try to solve it and see if you can get the answer right. Now let's go. If you have this 16 can always give you, you have 16 divided by 2, that will give you 8 divided by 2, this will give you 4 divided by 2, this will give you 2, and then divided by 2, this will give you 1. So we'll have 2 raised to power 4. So that means our 16 will be 2 raised to power 4 raised to power 5x minus 2. And that will be equal to 35 will be equal to 2 raised to power 5 raised to power 3x plus 1. So we'll simplify this. If we simplify this, we are going to have 2 raised to power 4 multiplied by everything out there, 4x minus 2, and this will be equal to 2 raised to power 5 multiplied by everything up there, 3x plus what? 1. So if we multiply that, we'll see that we'll have a common base, which will clear off. So we'll have 4 times 5, that will give us 20x, minus 4 times 2 is 8, equal to, this will give us 15x plus 5. So we'll collect like terms. If you collect like terms, we are going to have 20x plus 15 comes over here to give you minus 15x, and then we'll have plus 5. This comes over here to give you plus what? 8. And then this 20x minus 15, this will give us 5x equal to 13. So our x is equal to 13 over 5. So in this video, you've seen how you can solve exponents when they have common base and when they don't have common base. Now you've come to know the right time to use the logarithm and the right time not to use the logarithm. You do gain from this video. Don't forget to give this video a thumbs up, share it so that your friends can get it, and with your friends and colleagues you can share it. And don't forget to subscribe to this channel for more of our videos. Thanks so much for watching.